welcome back to the next lesson. In this lesson, we're going to be putting the motors onto the X drive, and then we'll put a brain onto it, and the brain will be what powers the motors, but that doesn't work in the CAD, of course. So we're just adding it there to make sure that the sizing would fit if we were building a whole robot. So I think in the first lesson, or no, not in the first lesson. So we haven't downloaded the V5 motors, which are the new motors. We haven't downloaded those yet for this project, so we just need to go to Chrome, go to Vex, V5 products, and then in the search bar, just search for V5 motor. And it's this one, the smart motor. So then just scroll down, CAD files. Always preview it just to make sure, just in case. And yep, that's what we want. So download. It'll take a couple seconds. It'll be the first step motor, or not step motor. It'll be the first step file in your downloads. So when we go back to Autodesk and you go to place it, just go to downloads and it'll be the first file. It'll be the first file right there. So open that. It'll bring up the converting the model. So just click OK. If you get a style conflict, just click OK and it'll update the style. And once it finishes loading, you'll get the motor on your cursor. So we'll just click it once for each corner. Press escape. And now if we zoom in on the wheels, on the motors, you can see that they already have this cylinder. So that cylinder makes it much easier when we want to constrain these wheels. So if we just click on the wheel and drag it out of the way for now. Now if we look on here, since the wheel is going through this hole right here, the axle will be. Oh, that's another thing we have to do. We have to put the axles in. So the axle will go through this hole when we put it there. So the wheel is going to constrain. One screw will go in there, and another screw will go in there. So we need to put those on. So since this doesn't have a circle right there, we'll need to add that. So click this part, find in the browser, right click it, and open it. And now we're going to go to the sketch that's on the front face, right click it, and edit it. We're going to project the geometry of this last hole over here. Then use the tangent circle just to get our hole like we did a lot last lesson. Then finish the sketch. Save it to make sure that it updates in the new assembly. Then we go back and now we have all the holes we need. So just constrain. And when you zoom in on this motor, you need to make sure that you find that inner line. You don't want this outer circle where it's just a point, or the face right here. You want to make sure you're getting that inner axis. So click that, and then go and click this circle. Make sure you get the axis. And it'll put it like that. However, that's the wrong orientation. So click a line to flip it, but then put it undirected just in case it needs to move eventually. And now drag it back so that we can look at the other hole. Constrain, click the second axis, and make sure you get that inner axis of the motor. And you can see it flips it again, so flip it back, and then put it undirected just so that we won't get any errors. Then click apply. Now when you screw the motor in, these outer brass parts, so if you look at it from this angle, you can see that these little brass parts stick out a bit, but those little brass parts seat into the holes. You can see there's some depth to the hole of the C channel, those seat into the C channel. So it's really the outer face of this plastic that's going to be touching the inside of the C channel. So we grab that face right there, and then go from the opposite angle, and we click this face, and then it'll line up properly. And now we just have to repeat that for the other three motors. So let's go to this side, drag the wheel out, zoom in a bit more. Now this part of the motor where the axle will go into has to line up with that hole. So first, we make sure we constrain the axis and click the center hole, reverse direction so that it faces towards us. Click apply. Now this is the axis that we want the other one to go to because we want to rotate the motor. So click that axis and then click the center of the motor and it'll flip it. Then click apply. And since this little plastic bit sticks through the metal right now, we can just click it straight from this view. Then go to the other side and click this interface and click OK. And it's as quick as that. And the more times you do it, the quicker you'll get at it. See, they don't move anymore. So they're fully constrained. Now let's do the third one. This motor will have to change the view to see the holes. So click on it, go to free rotate, and just drag it along one axis so that you can see the holes. And press escape, constrain, pick the first axis. That'll be going on this hole. Change the direction. Now this axis is going to go on this one in order to rotate the motor. So click that and the motor flips. Now this plastic piece right here is what's going to touch the actual metal. So just click that and then go to the other side and click this face. Okay, and now for the fourth time. Once again, you can use free rotate. Free rotate is a tool just to change a single part to look at it at a different orientation. So click free rotate and then click the part and you can rotate it along each axis. Or like in all three at once. So just move it so that we can see inside of there and press escape. Pull this wheel back so that we can see in there. Constrain. Pick the first axis. pick this is the one that we had to cut in order to fit that length there, but it's still this hole right there. So if you can see, once I do it, it applies it. Now we need to drag it back in order to see that other hole. So we click that one, click that axis, and put it, like, this is one of those times when you have to put it undirected, because if you accidentally put it in the wrong orientation, it would give you an error. So like if I put in this orientation and I click apply, it puts it in the wrong orientation. But you can come up here and just click undo once and it'll put it back. So go back to constrain, click the axis and put unaligned, apply, then just click the plastic face again and click the inner wall and click OK and it'll take it there. So now you have all 4 motors on, and make sure to save your file. So the next part is we have to put axles into each of these motors that will go onto the wheels. So I'll bring the wheels closer just so that when we put the axles in, it'll be easier to have everything in the view. So I'm pretty sure there's axle parts in the folder. So if you go to wherever you have the kit of parts and you go to motion, yeah, you go to motion and you scroll down, you have 2-inch axles, 3-inch axles, 4-inch axles, 12-inch axles. So what you can do is you can right click just anywhere and you can click measure and then you can just zoom in and you can measure anything you want. So you can measure from like right there to this face and see that's a little over 2 inches. So then if the axle is going a bit into the motor and it's sticking out a bit, we're probably going to want a 3-inch or a 4-inch axle. So then if we go back to place and we scroll down to our axles, I think a 3-inch shaft will probably work. And we can do 4-inch just to be safe, I guess. If you're actually counting this specifically, you could just switch out the shaft if it's too long. So we'll open the 4-inch one. And we're going to place it. Now what we do is we hit constrain. We grab one face of the axle. It doesn't matter which face. And we have this little insert right here. We grab one face of that insert. And you can see it'll stick it in there at an angle. And click OK. And that will constrain it along that face. So you can see when I rotate it, it goes side to side, but it's staying along that one face. Now the first face, it didn't matter which one we constrained it to, but the second one it does. So if we hold this right there, we know this top side of the axle is, well, really what we constrained is this right side of the axle. We constrained it to that face on the right side. So now that it has an orientation, we have to make sure that the second one matches the first one. So since this right side is touching this right side, this bottom face that is facing us has to be constrained to the bottom right here. So we'll go to constrain, we'll click that bottom face, and then grab the view cube and rotate it, and then use your middle mouse button to grab it and move it, and zoom in on that bottom face, and then click that one, and it'll line up. And then click OK. And now if you look at it straight on, you can see that it's in line with the axle. And when the wheel moves, the axle moves. So now if we go back to the home view, this wheel still isn't constrained to the motor yet, so it can still move like this. And in actuality, the motor wouldn't be able to move like that. But this wheel is constrained to this circle right here on the metal. We know that the axis of the axle, the central axis of the axle, is also in line with that motor. So it's going directly into there. So the next step is to click this metal piece right here, right click it in the browser, and go to visibility, and click that so that it turns off, so that we can see the motor. Now the motor is still constrained there, and the metal piece still exists, we just can't see it. So now, if we take an angle with the view cube, so that we can see all the way back into that motor, you can see that there's this first outer rim that's bigger. A high strength axle will fit in there, which we'll go over that later. So if you needed something that has a high torque application on your robot, you would use a high strength axle and put it in there. But since this is low strength, it'll go all the way into the back, into this smaller hole for a low strength axle, which is what this is. So we'll hit constrain, and we'll grab that face all the way in the back, and click the other side of the view cube, and click this face, the flat part of the axle right there, and it'll pull it into the motor against that face. So then click OK. And now when you look at it from the top, the axle can still spin, but it's in that motor. Now the wheel is not necessarily constrained to the axle, so it can still move. And the way to fix that is to know where this axle is, and also where you want the wheel to be. So in the browser, you can see that it's grayed out, this C channel over here. That's the one that we made invisible. When you make something invisible, it grays it out. So right click it and click visibility to turn back on. Now, if we were actually building this, this wouldn't just be floating here with the axle as the only thing to hold it. You would have a collar in here to screw into the axle to make sure that it doesn't slide in and out. And you would also have some spacers to make sure that this is the right distance from either side of the metal. So the way to simulate that is you can just constrain and turn this so you can see the inside of that face. If I can grab it right there, that interface, and then turn the other way, to grab that face of the insert. Because if there was a spacer there, it would be touching that face and that insert. So You see how it didn't snap into place even though I have previews on, which means either there's an error or the computer doesn't want to calculate it because it knows it'll be too heavy. So if I switch it, it doesn't snap into place either, so I know it's probably an error. So I'll just keep it on this one. And right here for offset, right now it's at 0. If I put like a 1/4 inch spacer in there, which is pretty common, like that's probably what I would put in there, and I click OK, you can see that it spaces it a 1/4 inch away, but it can no longer move side to side now. Now, if you wanted to change that because that's too close, like the wheel's going to rub against that piece of metal. So I'll click the wheel and I'll go down here to the mate, and you can see that it says 0.25, so you know that's the constraint that I did, and just click it and then change it to like 1/2 inch and then press enter and it pushes it away. So now it's 1/2 inch away. So just change that number to whatever spacer you would be putting there. And then you would just do the same for all of the other wheels. So we can grab this axle and just drag it out to each of the wheels. Now, if I wasn't doing this in a lesson format and I was just doing it on my own, I would have made this entire part, the whole part that's highlighted, I would have made that, and right now I would copy it and put it onto each of these corners because it's exactly the same. Now in some designs they might be slightly different. Like if you wanted to rotate this motor so that it screws in over here just so that you have space right here for something, they wouldn't necessarily be the same. But right now you could just take that and Control C and click stop. Wait, I'm not sure if it grabbed that C channel. Yeah, it grabbed everything. So Control C, then click over here and Control V. Now, this is one of those cases where it probably would have been better to make this its own part because now you'd have to cut this each time. So you just have to figure out when it's better to make a new part and when it's better to just use the parts that they already have and cut it down. So let's just go the other route and put each of these axles in. So like before, we'll click this metal piece and turn off visibility. Then click constrain, grab one side of the axle, and grab one side of this inner part of the insert. And that'll make it rotate. And then click apply. And usually it'll put it, since it'll spawn in at this angle, so we can grab that face right now and grab that flat face and it'll rotate it. So you just need to be looking out for those easy constraints where it already puts it closer so you don't have to move things every time. So now angle your view. If the wheel gets in the way, just press escape to get rid of the menu and drag the wheel back. And just rotate it so you can see all the way back in there. Click that face, then rotate it. We want this part of the axle. Then click OK. Now turn visibility back on for that. And we'll do the same constraint as the other wheel, because you're going to want these to be symmetrical. So hit constraint, grab that face right there, change the view so you can grab that metal plate, and then put a 0.5 offset, half an inch. And now these two wheels are done. And save reminder. Now let's do the back two. Pull the wheel back a bit, click the C channel, turn off visibility, constrain, grab one side of the axle, grab one side of the inner insert, click OK. Now if I drag this back just a bit, and if I twist it, then go back into constrain, I can grab that inner face right there now. So I click that one, and that puts it in line. And now sometimes you'll get in these odd views, just go over to the view cube and click a corner or something, and it'll bring you back. So now hit constrain. Let's get to the back of that motor. Then go to the opposite view so we can grab that face of the axle. Then click OK. Bring the C channel back. Constrain. We're going to be constraining this face to this metal face with a ½ inch offset. And just check from the top to make sure it looks fine. And the wheel spins. So now let's do the last wheel. Select the C channel, right click, visibility off, constrain, grab one side of the axle, grab one side of the insert, click OK. Now, on this one it's sliding that way, so I'll constrain this face to that face. And then zoom out, reset my view, look for the inside of that motor, go to the opposite corner to look at it, and grab the, oops, I clicked the wrong face there. You can tell because I had that metal circle. So if I hit cancel to go back, I accidentally hit that metal point, but I want the face. So find the inside here. Now bring the C channel back. And again, constrain the insert to the inside face. And put a ½ inch offset just to match the rest of them. And now you've added all the motors. So make sure to save it. Now, a part that you don't have to cat it, but if you were being super meticulous about your catting, you would do it, is axle guides. So if we were actually, I'll put the axle guides on here to show you how we would do it if we were actually building. So every time you have an axle that's going through a piece of metal, you usually want to have an axle guide, which basically helps things run smoother, because if you look at this right now, when you click on the axle, you can see that there's this like giant gap around it. So what an axle guide does is it basically closes that gap to about the size of the tangent circles that we make in order to help the axle run smoother. So I think that part should be in the kit of materials that we downloaded. It might actually be in motion. So here they call it a bearing flat. It's the same thing, axle guide, bearing flat, whatever. So we'll open that and we'll put 2 on each corner, and I'll show you why in a second. So if I take the wheel, and for this part it's probably easier if they're not visible, removing associativity is usually fine. We can do it for the wheels. So right here, right past the motor, the axle goes through metal, so you should have an axle guide there. So we'll constrain, and these are pretty simple. You just grab the center, so that center axis, and we'll be putting on this one. Put it on the other direction, and drag it out just so that you can constrain the other one. And now when it goes against this wall, you click the metal, and then on an axle guide, when it actually goes into the metal, you see these little pokey edges on each corner. Those go into the squares in order to help it seat better. So when we constrain, we don't want those pokey edges, we want the face beyond the pokey edges. So then click the other side, click the metal, and it goes against it. And this is how so if you're actually doing this, you get a screw that's just a bit longer, and it goes through the axle guide into the motor. And now this raises a question for the wheel, because if we bring the wheel back for a second, you need to make sure this axle guide fits. So, oops. If you look at it from this angle, which one is it? It's this one. Look at it from this angle. So, you can see that even though from the top it doesn't look like it'll fit, this will actually fit. Now the wheel might be pushed a bit more outward if you had a bigger spacer here. But you can see that when this spins, if you look at it from, let's say, this view, if you get it from the top, you can see that the edge of the wheel isn't actually hitting it. So this thing spins fine. So then for the other axle guide, we do the same thing. You just grab the center, put it unaligned, apply it, and now whenever I can, I like to put the axle guide inside of this lip. So if you look at it from this angle, you can see that the C channel makes a C right there. Whenever I can, I like to put the axle guide on this side of the C, not this side of the C. Just because when it's on this side of the C, it has no, like the C channel is taking up more space than it, like nothing's protruding from the C channel. This one we're required to put it on the outside of the C channel because if you put it on the same side as the motor, those brass rings that I showed you earlier, those break off and get messed up because they're being put into the plastic of this. So whenever you do a motor, the axle guide has to go on the opposite side. But if it's not directly connected to a motor, it's better to put it on the inner part of this C. So now we'll grab the other one. We'll grab this ring on the C channel and that axis, and then grab the inner face and grab the big flat face of that axle guide. Now if you look at it, you can see it's on the outside. So you would put screws into this, of course, but catting every single screw takes so much time, and you know that a screw is going to have to go there. So if I was actually making this, I would probably, since the wheel has to be pushed in a bit, I would probably put the nut on this side and the screw head on this side so that I can access the screw head more easily, and I could just stick a wrench down here in order to tighten it, because the wheel is going to be pushed this way enough that the nuts won't interfere too much. So you could put them on the inside. So then you just do the same for each one. And this is why I don't usually put axle guides unless I'm trying to test if something fits, because it's very um, meticulous, or not meticulous, it's very, I don't know, it's just annoying to put them all in. So unless you have to check the size of something, it's better to focus on making sure the overall mechanism works instead of focusing on making sure each axle guide is in the proper place. And remember, if you can, try to grab the circles without moving it. So I can tell that's the inside of the axle guide, and that's, if I can grab it, that's the inside of the square on the metal. And drag it out. Click the metal face. And whenever you finish constraining something, just grab it and try to shake it around just to make sure that it either doesn't move or it only moves in the way that you want it to. So make sure that you grab the axle guide, the inner circle. And now see, so when I did those two cylindrical axis lines, I made sure they were unaligned. So now even though this axle guide is in the wrong orientation, I can just click that face, and the axes switch the orientation in which they were connected, so that's in the way that I want it to. Which is why it's useful to make sure you use cylindrical, unaligned, or undirected. Because see, once again, it's in the wrong orientation. If I can just drag it forward a bit, grab the flat face, and it switches. And now on the last side, once you get the hang of these constraints, you can do things very quickly. Also, the hotkey for constraints is C, so you can just press C, and it brings up the menu. And if you spend time learning the hotkeys, it helps you save a lot of time in the long run. So from now on, I'll probably start using C for constrain, just because you've seen me hit the button so many times. You know where it is if you need it, and now you can just start using C. So that's everything constrained. So if I bring back the visibility of these wheels, and make sure to save, and now you have an X drive. So, what was the other thing? The brain. So let's go back to Vex products and just search up V5 brain, and it's right there. And if you go to CAD files, preview the brain, that's what it looks like. So we'll download that. So if we come back, go to place, go to downloads, it'll be the first thing. Just click OK on the import folder. There we go. So now you have the brain. So now when you're going to place the brain, usually it's better to design your whole robot to make sure that it works right and it'll work in the most efficient way you want it to, and then figure out where the brain goes, and then just route wires to it wherever you need. Since this isn't an actual competition robot, you can kind of just put it wherever you want. So if we go to the back of the brain, these 4 holes on the back, the inner holes, the outer holes are actual screws holding the brain together, but these inner holes are just threaded areas that you can put Vex screws into. So you would just take it and like go against this piece of metal, and if you're catting, you would just draw more holes, and you just line it up like that, so you can screw it in. Now, since you know how to make the drawing on it now, I won't actually do that, but what I'll do is I'll constrain it just to that plate so it stays out of our way. So since there's like texture on this back piece, they have it in different photos, or they have it in different layers. It's like you have that inner layer and the outer layer. Oops, zoomed in too far. You can just pick this layer that's next to the screws. And now, then just click that. And you would just screw it into the back. And now you would take the wire from in there and put it into each of these ports. And this 4-hole port, that's for the battery wire. The battery wire goes in there. This one's a micro USB. So that's for downloading code and stuff like that. Although there's wireless downloads, so the real way that we usually download code is you plug a battery into here. Oh, that's another thing. If we go back to V5 products, every robot has to have a VEX radio. So a V5 robot radio. This basically gets plugged into the brain and it receives signals from the controller. So those little lights will light up and they'll change color depending on connection, and they'll blink differently whether the connection's good or bad or it lost connection. And it has two holes in the back for you to screw it in. So that can plug into any of these because it has the same, this is the same wire type on the bottom. So that can plug into any of these holes, and you connect the controller to it, put a battery in the brain, and then plug the controller into the computer. And when you download it to the controller, it downloads over the radio into the brain. So you never actually have to try to access the brain if it's somewhere hard to get to on the robot. You never have to access it to download new code every time. And on this side, you have these rectangles with a little lip on the top. These are basically for old sensors. So if you look at something from the electrical system before V5 came out, so like optical shaft encoders are the most common. That's what these are for. These get plugged into there, and you have 8 of them, just so that you can use old sensors with the new brain, so you don't have to buy all new sensors, because they haven't finished making all the new sensors. And I guess for one last thing, I'll just show you what collars look like. It's just so that when you're actually building, you'll know what they look like and what they're used for. So if we go to the kit of parts, I'm not sure. Okay, so if you go into motion in the kit of parts under shaft coupler, and you open that, you usually only need to put one on an axle that's in this type of situation. Now you can put it wherever you want on the axle as long as it will hold it in. So first since there's oops, since there's an inner circular area of this collar, we can select that inner circular area, and then wait here. Yeah, so select the inner circular area, then you can select the circle on the wheel. I'm going to make the axle invisible just to make it easier. So constrain the inner circle of the wheel just because that'll keep it in line with the wheel, and the inner cylinder of that. And I'll just put undirected because it doesn't matter. So where'd it go? Let's pull that out. So what a shaft collar does is you just tighten down the little screw in the top, and it goes in the side and pinches the shaft so that it can't slide out. So now if I put it right there, it wouldn't actually do anything because it would be able to slide this way with the entire axle. So putting it there isn't actually doing anything. Now if I put it right here, it can't go that way once it's tightened. So this is actually a good place to put it. Now some people put it all the way in there. That's all right, It's just harder to get to. It works the same because it can't come out at all. And now, if this was right here, if I have enough spacers inside that it builds up to the collar, it can't go that way either. And also, if you need to make sure to put the axle all the way into the motor so it can't get pushed in any further. Usually you push the axle all the way in, then put a collar to stop it from falling out, because if it's pushed all the way in and it can't fall out, then you're fine. Usually you don't have a problem with it going in unless it's not connected to a motor and it's an axle and something else. So I would say just put your collars right here usually, so we can just constrain, select the interface of the collar, or the flat side of the collar. Select the flat face right there, then click OK. And let's bring the axle back. So you put this on there and then screw it into the axle, and the axle wouldn't be able to come out anymore. So that completes the X drive. That's how a simple X drive is built. You can take this design and mess with it a bit however you want in order to make it fit the design needs of whatever the season is. This is a very versatile drive because it can go in any direction. It's holonomic and it can rotate while driving, which is useful. So yeah, just use it however you will.